Here we learn about a new notion in real analysis, and which is a limit point of a set. And to define the limit point, we need a very important notion, that is neighborhood of a point. So first of all, recall that one. So we sketch the real line, and we take any point P in R and epsilon as positive. Then P minus epsilon will be on the left of the point P, and P plus epsilon will be on the right of the point P. Then the neighborhood, uh, this one, P minus epsilon, P plus epsilon, is called the epsilon neighborhood of the point P, and it is denoted by n epsilon P, where P is called the center of this epsilon neighborhood of the point P, and epsilon is its radius, because its center and this distance is epsilon, which is radius, this one. And now if we uh, delete the point P from this epsilon neighborhood, suppose P has been deleted from this epsilon neighborhood, then we get P minus epsilon, P plus epsilon minus singleton P. And in this case we say that this set is the deleted epsilon neighborhood of the point P, and is denoted by n epsilon P prime. So this is deleted epsilon neighborhood of the point P, and this one epsilon neighborhood of the point P. Now we are to define the limit point of a set. So definition: let A be a subset of R, then a point P in R is called a limit point, is called a limit point of this set A if every neighborhood of the point P contains at least one point of A, and that point will be different from the point P other than P. Here the point P may be in the set A or may not be. So let us take this example. So let A be the set containing the elements 1, half, 1 by 3, dot dot, etc. Now we sketch the real line, and we try to plot these points of the set on this line. So the first term is 1, and the second one is half. If we take this one is 0, so in the middle it will be half. It is 1 by 3, 1 by 4 will be here, and 1 by 5 will be here, etc. So the terms are decreasing and approaching 0 from the right. we can say this one. Now we claim that this 0 will be a limit point of this set A. So for we have to show that every neighborhood of the point 0 will contain at least one point of this set A. So let us try to find that one. So let epsilon is greater than 0. Now we use Archimedean property. So we draw another line, and here we say that if we take this one as 0, it's 0.1, and epsilon is positive, so epsilon will be on the right of the point 0. Then by Archimedean property, then by Archimedean property, there exists a positive integer k belongs to n such that 1 by k will be in between 0 and epsilon, such that 0 less than 1 by k less than epsilon. Now if this is 0 and this is epsilon, so minus epsilon will be on the left of 0 over here, and then we can write minus epsilon will be on the left of 0, so minus epsilon will be less than 0, and 0 is less than 1 by k, and 1 by k is less than epsilon. That is, we can write 0 minus epsilon less than 1 by k less than 0 plus epsilon. That is 1 by k will be in the open interval minus epsilon, this one. So 1 by k is in minus epsilon. So this is a neighborhood of the point 0. Now 1 by k, since k is in natural number, then 1 by k is of the form this one. So 1 by k is in A, as well as 1 by k is in this neighborhood. That is, therefore 1 by k belongs to this one minus epsilon plus epsilon intersection with the set A. So this neighborhood contains a point of A, 1 by k, and 1 by k is different from 0. Also here 0 is not in A. So this, also epsilon is positive, which was arbitrarily chosen. So we say that every neighborhood of the point 0, here minus epsilon is a neighborhood of 0, and since epsilon is positively chosen, so this denotes that every neighborhood of the point 0 contains at least one point of the set A different from 0. Here 0 is not in A, so no problem here. So the conclusion is that 0 is a limit point of the set A. So 0 is a limit point of the set A. Thank you.